So this is our first lesson in Chapter 2, and this is what we did in today's lesson. We did our warm-up, we looked at the last few answers from Chapter 1, and we also went over the sum project, which the quizzes are going to start for next lesson. The first lesson in Chapter 2, we're specifically going to look at SURDS, which is the AICE word for that, and you're more familiar with the term radicals. I've posted a couple of websites here that you might want to use as well to try and practice your skills. These are also available on my School Fusion page for my students. Now, the specific objective for this chapter is, as you can see on the board here, and today specifically we're going to look at simplifying expressions involving square, cube and other roots. So why do we use surds or radicals? Well, because they're more accurate. We don't have decimals and have to round those decimals. And also, when do we use surds and radicals? Well, certainly you remember them from Pythagoras, hopefully. And also we actually used them in the last section when we did the distance formula. And some of you actually, when you had answers of like radical 20, went ahead and said it was 2 radical 5, so that's a good sign already. So when it comes to simplifying a radical, what you're trying to do is make the number inside the square root just smaller. And one way of doing this is to know your perfect squares. So perfect squares are all the numbers multiplied by themselves. So what I'm writing down here is 6 times 6, 7 times 7, 8 times 8, 9 times 9, and 100, and 10 times 10, which is 100. So for 12, I need to find two numbers at times to make 12, but one of them is a perfect square. So knowing your times table is very useful for this one. So 12 would be 4 and 3, and the square root of 4 is 2. And I've simplified this radical because I started with 12 inside, and now I've finished with 3, so that would be a simpler radical. Now when it comes to 80, I noticed that 4 certainly divides into 80 20 times, and the square root of 4 is 2. And also I can carry on with this because 20 I notice also, once again, I could use 4 again. I could say this is 4 times 5, and the square root of 4 is 2, times by this 2 gives me 4, and once again I managed to simplify that radical. Now, depending on how good your knowledge of tables is, you might also spot straight away 16 actually divides into 80. And then the square root of 16 is 4. And actually, I've finished the question in a fraction of the time. So the bigger the perfect square that you can find will make this task a lot easier. Now, I'm going fairly quickly because this is stuff that's been covered in Algebra 1 and also Algebra 2. So if you need more in-depth notes, make sure you go look for those. Adding and subtracting radicals. So remember, you can only add them together if they have the same radical. So this question here I can't immediately simplify because one's radical 8 and one's radical 2. So 8 I can split up as 4 and 2 though. The square root of 4 is 2, times 3 is 6. So I got 6 radical 2 minus radical 2. Remember, if there's no number in front of the radical, that means we've got one of them. So just like x is 1x, same idea with this. So 6 radical 2, take away 1 radical 2, would give me 5 radical 2. So this is one of the reasons why we're actually going to be using simplifying radicals, so we can actually simplify more complicated expressions later. Can't subtract yet because these are different radicals. 12 was one we had earlier, that's going to be 4 and 3. And 27, once we know that one of the numbers is 3, we can use that as a clue to help simplify this. So 3's into 27 go 9. If we're being asked to simplify, there should be something in common with this once we've worked this out. So the square root of 4 is 2, times by 3 is 6, so this should be 6 radical 3. Square root of 9 is 3, times 4 is 12. And it looks like I got a little mistake there on my notes, so I'm going to quickly change that to 12. And then 6 radical 3, take away 12 radical 3, should be negative 6 radical 3. The other thing is rationalizing the denominator, which actually comes in with divided by radicals. So remember, you're not allowed to leave a radical on the bottom of a fraction, so we're going to rationalize that. And the English spelling is with an S there. So if I have something like 6 over radical 2, all I'm going to do is times top and bottom of this expression by that same radical. And the reason that works is radical 2 times radical 2 is 2 radicals cancel each other out and just leave me with the number. Some people start saying 2 times 2 is 4 and then the square root of 4 is 2. And that's fine and it will work, but you can just simply take the number itself. You wouldn't want to do that if I gave you like the square root of 93. The square root of 93 times the square root of 93. It's just 93. 6 times radical 2 is just 6 radical 2. And then simplify like terms, so I got my numbers here. 6 divided by 2 is just very simply going to be 3. Now, the one that's more complicated is when you have a binomial expression on the bottom, and what we do is we multiply by the conjugate. Now, the conjugate is something you should have seen in Algebra 2. So the conjugate is the same expression but with a different sign. So if this one's negative, the conjugate is going to be positive, and vice versa. Make sure you times top and bottom by the same thing. Now, the reason we times by the conjugate is when we do 1 times 1, we get 1, which is rational. 1 times radical 2 isn't rational, but you also have negative 2 times 1, and those middle two terms are always going to cancel out. That's why we choose to do the conjugate. But also, the radical times the radical will also turn into something that is rational. So when we simplify, that's why we call this rationalizing a denominator. We start with something that's irrational, and then we change it into something that is rational. 1 take away 2 is negative 1. 6 divided by negative 1 gives us negative 6. So just a few reminders there on some of the key things that you would have done in Algebra 1 and Algebra 2 that will hopefully enable you to complete this exercise for today.